Assalamu alaikum. We continue with the data exploration. Few more plots to display quickly and visually the way the data is distributed, where is the central tendency, and how the data is dispersed around it. Generally speaking, there may be two ways of displaying a data distribution. One of them is digital, showing computed values on certain indices on this data set. And the other is visual. You could display a plot of the data distribution that provides also some very useful information. If we go through the digital form, you'll get things like the mean, the median, the variance, the standard deviation, the minimum, the maximum, the range, and so on. You also get an estimate about how this data set is skewed and how it is peaked. You get some very similar type of information in a second very quickly by just looking into a plot of this data, like a histogram, for example. You could tell here immediately that the central tendency is here somewhere around the 40 to 50 years. This is a set of data of patients' age with certain tumor, for example. You know that the central tendency will be here. There is dispersion around the central tendency, some less and some more, and you can also tell that the data is skewed because there is an aggregation of some older patients in there. So a visual display would give you a very good amount of information whether this data is normally distributed and where you would find the central tendency and how the data is dispersed. Another type of data plots that can provide useful information at a glance is the Box and Whisker plot. The same set of data about the patient's age can be displayed here in the Box and Whisker plot and provides all the information you may be looking for. You could see the central point, the median, in the middle of the box. The box is formed by marking the first quarter of the patient's distribution and the final quarter of the patient distribution. So this is the first quartile and this is the third quartile. And in between is the second quartile, which is by definition the median. So you could tell here that the median is correctly somewhere between 40 and 50 years, and that between the first and the third quartiles, that's to say 50% of the patients' age are between 40 and 50 years. The whiskers extend outside the box to mark out the fourth quartile and the beginning of the set of the data, the first quartile beginning as well. So you know that the spread for most of the patients will be below 60 years here and just below, for example, 30 years there. There are dots on the outside of the whiskers, and these are outliers. These are values too big to be included within the whiskers. The whiskers may extend 1.5 times the interquartile range. The interquartile range would contain 50% of the patients. So you can extend the whisker 1.5 that range in one or the other direction. But any value outside this will be marked as an outlier. You could see there are few outliers below that certain age here and more outliers above that age group there. So that's the Box and Whisker. In simple terms, it will give you the distribution of the middle 50% of the patient, here the median, and the distribution of the first 25% and the last quarter as well, and how many outliers you have beyond these limits. And this Box and Whisker type of plots are useful not only in descriptive statistics, but also in inferential statistics when you're trying to decide if a group is different from another, or if you're trying to find out evidence to support a certain idea or a certain hypothesis comparing groups. In this example, we'll be looking into the effect of the tumor margin on tumor recurrences of pleomorphic adenomas of the parotid. These are real figures. So we look into two groups here, the group of patients who did not have a recurrence, how their tumor margins, safety margins, are distributed, and the group that actually did had a recurrence. And they look different in the histograms, of course. But if you compare the box plots, you get also a good amount of information just at a glance. You can see here that the narrowest possible safety margin is of course 0. But in the group that did not have a recurrence, there is a good spread up to maybe more than 2 centimeters and sometimes 3 centimeters of a safety margin. That's a very good safety margin. That's why there were no recurrences in this group. But in the other group with the recurrences, most of the safety margins were 0 or just more than a 0. And you actually had never had any individual who had a safety margin more than 7 or 8 millimeters did had a recurrence. So know that all recurrences would happen below 8 millimeters. You see the same information and a little bit more with the box plots for this comparison. You can see that 50% of the patients who did not have a tumor were within the box in here between 0 and 10 millimeters. But there is also a spread beyond the 10 millimeters and some outliers because some patients had a very large safety margin. But the group that did had a recurrence, you can see that most of the patients are in here in the very early set here. Most of them are 0. That's where you would have the mean, and the spread above the median. This is the next 25% is very low indeed. So 75% of the patients who had a recurrence had a very limited safety margin, and only an outlier did had anything more than that. Now to more plots that can visually display the same set of data on tumor margins and recurrences. And this time we'll be exploring the violin and the density plots. And starting with the density plots, if this is the histogram of the patients who did not had a recurrence, and you can see how the data are distributed, most of them early enough, but it spreads up to 3 centimeters or so, with some outliers in here. If you want to smooth out this curve, you use the density plots with a function called the kernel density estimate. And this will sort of average the amount of information in here to smooth out the curve. And this will be the final plot, which is quite similar to the distribution of the histogram, but with a smoother curve. You could see the outliers here, and that the bulk of the patients were in this area. Now, if you rotate this density plot 90 degrees, you get this. And you use this with a mirror shape to it to get a violin plot. So the violin plot is just the density plot on its side, and with a mirror-shaped density plot of the same set of data, you get a violin plot, which again smooths out the curve so that you can see at a glance that most of the information is somewhere in here with some extension, and then it narrows afterwards to get all the outliers up to 3 centimeters. So that's the density plot in here, and that's the violin plot in there. Now you can add to this, you can put the actual data jitter into the violin plot. So you can see that at the 0 you have a lot of these information in here, and then you can have how many at each point along the plot. These are the data put like stacked like points along the violin. And you can add to the violin as well, which gives you the contour of the data distribution. You can add the box plot. So you can see here the box plot of the patients who did not have a recurrence. This is their median in there, and this is the third quartiles, and these are the actual plots along the path to the end of the violin, the 3 centimeters. And now to comparing the two groups, if we start with the raw data in there, these are the raw data jittered for the group who did not have a tumor recurrence and the group who did have the recurrence. And these are the same set of data, but rather than being jittered, it's now stacked. So you could see it in long columns along the path to the end of the plot. Now you can smooth out this by having the density plots for those who did not have the recurrence and those who did, and you can visually compare the two groups very quickly at a glance. If you want to get some more information, you can use the violin plot for the two in here, and you could see clearly that the violin for those who did have a recurrence is very wide indeed at the beginning, with a narrowing after this and a small amount of outliers at the end. But the violin here is quite different from the violin of the patients who did not have a recurrence, and the actual jitter data are also added to the plot. And finally, you can also add the box plot to the violin data for both those who did not and those who did have the tumor. So you can, by a quick look at this graph, decide that the patients who did had a recurrence have most of the patients have no tumor margin at all, and that's where you have most, about 50% of your cases, and 75% of those who did had a tumor recurrence were early enough. Only a few of the patients who had a tumor margin more than 6 or 7 millimeters at the very end. Whereas with the other plot, you can see how the data are distributed more evenly. By this, we come to the end on the visual display of the data using different types of plots. Assalamu alaikum.